We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shiftleft. Contrast Security enables organizations to secure their applications from development to production. By embedding security sensors within software, Contrast automatically and continuously detects vulnerabilities in both custom and open source code while developers write code, providing them with context-specific how-to-fix guidance for easy and fast remediation. At the same time, by identifying only true vulnerabilities that pose risk and eliminating those that do not, Contrast empowers developers and security teams to prioritize and focus on only those vulnerabilities that matter. Learn how Contrast can help you secure your applications from development through production at securityweekly.com/contrast. Whether you need to manage bots, protect cloud applications at runtime, stop form-jacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Do you want to stay in the loop on all things Security Weekly? Visit securityweekly.com/subscribe to, of course, subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list, join our Discord server, and follow us on our newest live streaming platform, Twitch. Security Weekly Unlocked will be held in person this December 5th through 7th at the Hilton Lake Buena Vista. We are excited to announce our speakers, although I'm always not excited to have to read through this whole list. So 1 second, it's huge, it's great. I'm going to take a breath, and we have Leslie Carhart, John Strand, Alyssa Miller, Dave Kennedy, O'Shea Bowens, Marina Savada, Patrick Coble, Chris Ang, Eric Escobar, Nick Leghorn, Michael Schlatt, Kevin Johnson, Justin Kohler, Jay Beal, Trenton Ivey, and Ryan Cobb. Visit securityweekly.com/unlocked to register and check out our exciting lineup. And we'll see next week if I can read the whole thing again in a single breath. Speaking of single breaths, now I messed up that segue already. I'm out of breath, John, because there are yet more vulnerabilities that have come up this week, and I'm out of breath maybe from excitement because the OWASP Top 10 has a new draft. But maybe let's save that for a little bit. You saw some vulnerabilities that popped up here. One of which was some cross-account container escaping takeovers. It's a long title for some bad things going on over in Azure. What's happening there?
Yeah. I'm going to talk about the vulnerability quickly and get that out of the way because it's another vulnerability. As you said, hey, another week, more vulnerabilities. That's what everyone listens for, right? But let's sort of go to the interesting part. So yes. Unit 42, we got a link in here. This is a Palo Alto, their threat research group. They did a pretty good write-up. Talking about they did a little bit of pokey and prodding on over at the Azure has this thing called ACI, similar to Amazon has Fargate. These are both what are called container as a service platforms, for folks who are not familiar. And what that means is instead of you having to run a VM with Docker or Kubernetes or whatever else, you take your container image, you throw it at the provider, you say, please run 10 of these. And they say yes, sir, and they do it. ACI is a little newer. Fargate's been around for a while. And it basically comes down to, okay, well, the problem with containers, to sort of talk through this, problem with containers is not a security concept, right? That's for containing to a degree, but not really. So what happens here is you go and you give them that container, they run it, and the unknown question, sort of slightly nebulous, is how do they do that isolation on the background, right? Fargate, I think we know is that's based off their, I'm going to forget now. It's based off their Firecracker VM, which they came up with. A lighter weight, smaller VM, because you don't want to be spinning up a new VM for every single container. We have micro VMs are out there that they take that route, but it's not really too efficient. Still a tiny bit slow speeding up or booting up. But so anyways, that's sort of the overall problem space. You've got a container which a customer is giving you. It's going to be run in let's reverse that. I have a container which I'm giving to provider. It's going to be run in some sort of a multi-tenant environment. The cloud provider needs to do this as securely as possible, but also doing it as cheaply as possible because they want to pack as many of those containers and customers into that server. Yeah, they're not going to give each customer their own server. So how do you do that? And that's sort of the problem statement. And to date, they've been fairly secure. We've been seeing some little issues here and there. But Unit 42, they did some poking around, and they have this cool container that they built. That part of the RunC container spec, the runtime for containers. I'm sort of babbling on here, but part of that specification is it actually tells the container what version of RunC is running. So this was their opening salvo, and they realized that the version running was, for politeness, I'm just going to say old. And that gave them sort of, I always talk about, finger holds when you're rock climbing or when you're sort of trying to, compromise a site. This was their first finger hold. From there, they went and they did some testing, and the article talks through how they managed to get in and get down to root on the host. And then started probing how can they get to other containers, which were owned by other tenants. They were able to figure out sort of the approximate size of a Kubernetes cluster. This is running on Kubernetes. They were able to figure out the approximate size of a Kubernetes cluster. They were doing some interesting attacks to sort of poking and prodding around and sort of do things like this. I think people listening so far can sort of figure out this isn't a good thing, right? And they patched it, and they've, it's now been released. So they work with Microsoft, and it was patched beforehand. And that's that. And I'm really not going to focus on that because there's anyone who's listened to me on this podcast this year can guess my thoughts on it. But I think what's interesting about having this conversation is two things from the Unit 42 post. One, they've got a really great, all sorts of good information in here. There's two images, figure 13 and 14. And it's basically once they've got root on that box, they're doing a kubectl to get a list of first what roles exist out there, right? So what roles are there, what's been granted, what can the container do in theory with the token which they managed to get, which again they shouldn't have, but they did. And then once you've got that, the second screenshot shows, okay, this is for my token that I have right now. Here's the roles I got. And the question they pose to the reader is, anything stand out? What can I do with this? And for those of us who know and familiar with Kubernetes, it's the first one that's listed is pods exec, and that particular resource has the ability for this user to run create with that, which means you can create pods, which means you sort of that's close to game over. But the question here is to think through, as any of us look at this, if we're trying to run Kubernetes and we're trying to, you're not a cloud provider, most of us aren't, right? I've done that before, don't try to do it. But if you are going to go down this path of trying to, run Kubernetes for your company or for multiple departments, how do you secure this big, crazy, complex thing? So that's sort of first thing to think through, looking at the screen and this list of sort of gibberish, to be quite honest, unless you really know what you're looking at in Kubernetes. I mean, this isn't something the average Kubernetes user looks at, right? This is how do you do role access control in Kubernetes? It's fairly complex. So that's the first thing. How do you look at something like this? How do you know you need to look at this, right? We were talked over the last few weeks. And as I think about it, it was actually the other Azure issue with Jupyter, right? By default, they were allowing, there was an allowance there around, long story short, if, we were talking about before you put something in production, you need to know what it is and how to secure it and what the feature flags are and what you need to turn off. How do you do this with Kubernetes? Is sort of, that's the first point I want to take away here. The second one I think is equally interesting. I'm not sure what type of traction we're going to get on it, but we've got another story in here talking about the guys at CISA, and I'm going to mispronounce it just to annoy people. But if we think about CISA and what they're doing and SBOMs and where Alan was previously, Alan Friedman, are we at a point where we need to have an SBOM from a cloud provider? the thought I want to put out there. Because really what happened here is the reason these vulnerabilities existed is you are running RunC version 1.0 and Kubernetes, I believe, version 1.10. Both of these are over 2 years old, if I remember right. These are technologies which are changing very rapidly, and we are trusting our cloud providers to keep up to date and secure. And they had some patches in there, so they were sort of trying. Security is about trust. I mean, I can't talk so much, right? I mean, at a personal level, at a company level, anything I do around security is really around trust. That's a core part of what our business is we have to be able to trust the providers we're using, the vendors we're using, the software that we write, all this type of thing. So the question is, how do we trust people who are able to do this? How can we build trust for SBOMs in this type of space? And I'll shut up. But that's sort of my thought process around this thing. And yeah.
Yeah, there's definitely some interesting themes here, and I had actually gone through another article this week that I didn't throw in for discussion. That was actually, is it time for SaaS bombs, which at least sound kind of cool and funky. But it's to your point. How much do we need to rely on cloud service providers to handle these types of situations for us? Because in this case, Azure did go through and apply some important patches to a lot of otherwise vulnerable instances, which I'm going to use to tie into the Confluence example, because here's Confluence had an RCE that I highlighted just for, once again, kind of a nice write-up. In this case, it's not a write-up about a compiled binary that turns into some C code. So it's actually some reverse engineering a patch, and then you could read through some of the code that was behind this, some Java and JavaScript. But some of the aspects of this tied into, I think, what you were saying, in the sense of, should we run our own on-prem or build our own cloud service multi-tenant scenario? And if we do so, how do we architect it in a way to separate, have strong security boundaries? Or in this case, a Confluence, are we running on-prem and we need to keep up to date with our patches, or can we transfer that risk? As to use a call out to our last episode, we had a conversation with Caroline, and say that we want the cloud service provider to be responsible for applying these patches, and cross our fingers, hopefully they're being pretty diligent about that. And
I get the company's point of view, right? I mean, if I put my vendor hat on for a second, do I want to put an SBOM out of every package that I'm using? That by itself is not, sensitive information or critical information, but it could sort of give my competitor some sort of an idea of how I'm doing the things I'm doing. So I sort of get that. Mm-hmm. But there has to be some sort of balance here between what's going on. I don't know. I don't have an answer on this one. I think we need to do something like that. I suspect if the government gets involved, it's going to be a lot of bureaucracy and really bad scene. But I don't have. You
broke John.
Yeah, no. I'm filtering really heavily today. But how can I? What does it take to be able to trust, right? I for years, and we've said on this podcast so many times about, don't run Kubernetes, trust the cloud providers. And I understand this isn't a Kubernetes service, but it's Kubernetes based. So, yes. But we've got so many people out there, all the server huggers who have always been like, and it's funny, I haven't heard from any of them. I'm sure they're like really shouting in glee on this, but all the server huggers are like, see, I told you can't trust the cloud. So what is that, for those of us who believe in this and have bought into it, what is that sort of balance point in between there, that we get enough information from these guys that they're doing the right thing, but without giving away trade secrets? I think that's something we're going to have, unfortunately.
Yeah, it sounds like it's not that cloud is untrustworthy. It's more of, we just need to have that equivalent confidence, and to a degree, I'll use the term observability, or maybe just visibility into the cloud practices so that we can have that confirmation that, in fact, yes, you are applying patches on a on a consistent basis, or immediately within, in this case, with the cloud service provider, you would understandably have some type of SLO with them where they would say, yes, we're applying patches within this time frame, or we're doing this over weekends or over holidays, important situations when attackers can take advantage of inattention or gaps in processes. So speaking of other, go ahead.
I'll leave this at this, I think, to put a technical spin on it. We've talked about, trusted computing and trusted platforms and all those sort of trusted hardware concepts, which basically at the end of the day allow a programmer or a user to attest to the state of a system. So I guess what I'm asking for, whether it's SBOM or something else, is how can we attest that the state of that system that we're using is within reason secure?
Indeed. And it sounds like we're starting to tease our way into some good practices, perhaps, and maybe some OWASP top 10. But before we get there, just run through a couple other quick vulnerabilities, because I think that might inform our follow-up conversation on these final articles from the perspective of building and defense. So real quick, there was a vulnerability in some NPM files that managed by GitHub. What the thing that stood out to me that was pretty interesting is that, go ahead, read the advisories, and they were doing the right thing in the sense of trying to sanitize values that were file paths. So of course, path traversal, that type of nature always appeals to me. But they were doing the sanitization, but the sanitization just wasn't quite right enough. So they were missing some, basically, what happens, you have 3 / in a row, or if you're missing on a Windows file path, if you just have C:.. So it was kind of interesting that they just had some good thought process, but they had an incomplete method of sanitizing and normalizing the data. So just a good lesson of saying maybe there is, how do you build test cases from a good security perspective, and maybe even throwing something like fuzzing at that, because the file paths are pretty predictable or pretty constrained domain of characters that can go in there. So if you have a mature enough org, perhaps that's something that would be profitable to do. So that's one of the things that stood out for me. John, you've also got one about some Wi-Fi applications and a bit of a shaky foundation in the use of credentials, I will say.
Yeah. And this is a fun one. There's 2 parts in here. I think I let myself focus on the first one, but the second one's sort of cool too. So this is Rapid7, our buddies over there, found some issues with the Fortress VPN and Wi-Fi system. And today we're just talking about Wi-Fi. But long story short, they had an unauthenticated API access, which, as we're saying, foreshadowing. But really, at the end of the day, what could happen is if someone knew your email address and they knew the API endpoint over at the cloud provider, I guess I should say SaaS provider, excuse me, they would be able to get the IMEI for your particular device. If you have the IMEI, which is, the mobile number, serial number, which all of us have on our cell phones, they could then turn around and take that and go back and say, I've got this, could you please reset your password? Long story short. Or actually, it wasn't even that. With the IMEI and that email address, that's all you needed for credentials. So you didn't need a password. You could actually go in and say, hey, could you disarm this system? And I'm babbling around here a little bit, but we're talking about VPNs and Wi-Fi. This is actually a Wi-Fi issue on Fortress's security product. So this is a at-home it's your at-home security thing for some of us who have or not some of us, people who have like they want to do sort of IoT or DIY security systems. You buy something like this, you throw on a wall, you have a few Wi-Fi or Bluetooth security things around your house, like window sensors, door sensors, that type of thing. That's the space we're talking about. So for someone to be able to come in with the IMEI, for someone to be able to grab the IMEI with your email address and then turn around, point back at your system and say, could you please disarm that security system? Not the best thing, right? We've in the past, every time we have a new IoT thing come up, people are always like, oh, how can you get into it? The locks in people's doors and stuff like that. But that's the first part of it. The second part's actually probably, depending on the sophistication of the attacker, more interesting. We have seen attackers which are doing things like doing replays on car alarms and other sort of entry systems to be able to unlock a door after someone thinks they've locked their car and left. The second thing with this is actually an RF replay. So, we usually talk on here about replay attacks for APIs or, texty type things. But in this particular case, if someone can record that series of frequencies which are used, say, on a key fob to unarm your house, they can go back and replay that multiple times. So there's no, think about put an AppSec spin on this. How would you actually make sure that that can't be replayed, right? There's several different ways to do it. So that's what they're not doing here. And this is sort of the problem what we see with some of these relatively newer IoT and just general security type products. And this is sort of how we end up in a space like this. So more foreshadowing.
More foreshadowing, exactly. Basically, the kind of the conceptual idea that here's a protocol for our key fob to unlock, and we're going to send this packet. Just so happens this packet is a nice bit of frequency spectrum. And if we replay that, we can replay that. No integrity checking, no authentication, no authenticity. Similar to another quick comment on a vulnerability in WhatsApp that, again, once it sounds familiar, it does go into the C code this time once again, and a little bit of binary reverse engineering, but pretty neat because it was some fuzzing that identified a flaw in a GIF image that bypassed a little bit of tricky logic in the assumptions that this application had between 4 bytes of a map field, if you will, describing a pixel or describing attributes of the image. And then if you just say, well, what if we just actually send something that is 1 byte that's describing the same thing? And then you start to get into things like buffer overruns and out of bounds reads that turn into RCEs. So once again, this is more of just a repetition of images are a great attack surface. We've seen this in many, many different ways. So part of the thing is, I think here is the thought process of why aren't we doing image manipulation, image handling in memory safe languages? Because we shouldn't. I think it's too hard to talk about just refactoring, rewriting all of our existing code and out of C into something else. It could be Go, Rust, what have you. Pick your favorite. But the Linux kernel isn't doing that with its, 5 million lines of code or so, which was focusing on drivers. Same thing with Android. Certain parts of Android are just focusing on its more vulnerable attack surface. Same thing we've seen in browsers, Firefox, I believe. And here, WhatsApp is a great point for doing the same thing with their image handling functions. So it's that idea that, yeah, go ahead.
I was just going to say, it's coming back a little bit to what Manesh was talking about in the last segment too, right? Of like, if you provide, the initial analogy was if you give someone 100 vulns, they're not going to fix it. How do you triage that down to something you actually think about? And the same thing, we're not going to rewrite a whole application in Rust, but if you can sort of figure out where do we want to start, where's our sort of sensitive bits? Yeah.
Where are sensitive bits? It's almost as if these are some bad practices to write your image handling code or a parser in a memory unsafe language. And that's my segue into just 3 simple bad practices that CISA has given out here. Use of end-of-life software. Again, great callback to a conversation we're having with Manish and tech debt, which admittedly saying don't use or be aware of your tech debt is a lot easier to say rather than figuring out how to execute on that. But the other 2, I think, are pretty straightforward. Avoiding known fixed default passwords and getting away everywhere, not just from administrative access, from single authentication. I would say throw your FIDO keys out there and use WebAuthn, because that gives you great cryptographic backing as well as cryptographic confirmation of the domains that you're talking to. So there's many great reasons why it's resistant to phishing, even resistance from accidental tapping, because the crypto behind the scenes is actually going to protect you quite well. So that's what it was, just a list of 3 things. There's an ongoing discussion about what else should be a bad practice to avoid. So I encourage people to go check that out. Links in the show notes. Not sure if there's anything else on that topic that stood out for you, John. And then if there is, let's have it. Otherwise, it's time for the OWASP Top 10.
No, I was looking through went into the discussion, and it took me a second because GitHub has changed what their discussion board looks like, so it's that's certainly neat. But it's just getting started. I think if people want to make a difference, if I think about some of the different things I've done over the past, CNCF, Apache Cloud Stack, some of these different platforms, if you're able to get in early, Cloud Security Alliance, this is when you can actually start to make a change on some of these things or have a bigger effect for folks who want to, get their name in lights and be someday on a podcast. But this is it's a pretty good time to get in and start talking about what are these bad practices and how can you help sort of qualify and document and catalog those.
Yeah, I think one final comment for me on that was that the reason I liked them is that they were pretty clear and straightforward bad practices that I think are pretty universally acknowledged that these shouldn't be done. And I think they have pretty clear actions to take from them. There's a lot of things that you can say these are best practices or these are good practices, but it's kind of hard to say, are these the best practices for everyone's context, for everyone's threat model, or not? Whereas, which means you have to have longer conversations, which means you get into like how much of this should be a standard versus just this is a policy versus this is something we're going to create from a framework or create by default. And that leads into things like perhaps something like the OWASP Top 10, which I will say up front, they say in their introduction, it's a awareness document. The OWASP Top 10 is to build awareness about problems that have plagued the web application security industry for longer than the OWASP organization has been around. So OWASP is turning 20 years old this month, but these web vulnerabilities predated OWASP. So we've got a new Top 10. I've got some of my own opinions, but John, let's hear some more of your opinions. You've had many this episode so far, so let's get them all out.
I'm going to challenge you on one thing there you just said.
All right.
What was AO4 from the 2017 version, XML external entities, XXE, was that around 20 years ago? I can't remember exactly when XML started, not to mention the beast, but...
Oh, that's anyways, okay.
Maybe it's around that time. It's interesting, and quite honestly, me being the visual guy, I just like the chart at the top with the arrows pointing back and forth so I can see what went where. Broken auth dropped down from 2nd to 7th, and also I've been watching Formula 1 races, so I've got my head thinking about things going back and forward. I think it was, so I don't know, part of me, and I think I probably had this thought before, and I know my listeners are going to send in the hate mail, because I sometimes will confuse authorization and authentication when it comes out of my mouth. I understand the difference. Should they be two separate OWASP things? That's one thought there. Broken auth drops down, but authorization comes up. I think that's interesting. I think it sort of echoes what we've been saying to a degree. I don't think XML entries dropped down far enough. Again, as I was asking Manish, please tell me what the world's like outside my bubble. There's probably still plenty of people using XML out there. Injection. And then the one new one, server-side request forgery. I thought that was interesting to put on here. It's interesting. It's not massively different to me. I'd love to see a little bit of data behind how they organize this. And from what I read, I haven't seen that yet. It's probably out there. I know these guys aren't just picking up stuff off the top of their head, but that's sort of my...
Yeah, I can help you a bit about that. A lot of what they did this time was saying, well, here are what are all the CWEs related that you've come across, that you, security industry, have come across in web security. And what they essentially did was say, look at the CWEs and weight the CVSS scores behind them and say, it looks like broken access control seems to be weighted the most in terms of how many CWEs are in there and what the average CVSS scores were with them. So it's roughly a prioritized list of the most impactful or most prevalent vulns that they've seen, down to the bottom, which actually SSRF was sort of thrown in there by fiat, by opinion, saying that the data didn't really support that it's really prevalent. But probably, I'm going to guess, there's a little bit of the anecdotes saying that if you get a SSRF in a cloud service provider and you get access to the metadata service, then it can be game over. So they sort of just wanted to throw in that vuln. But I think, to me, I'd step back a little bit and say, okay, fine. We have essentially what's a catalog of a bunch of CWEs. It's been given and organized into a list of 10 things because a list of 10. People like top 10 lists. But my challenge, the question to them is that when we get beyond using this as a document for awareness, how do we use it? And this year, the draft does go into should you or how should you use this as part of as a base for a application security program, or does this actually lend itself to being a standard, or should something else be a standard? And the reason I'm harping on this aspect is that it's sort of hard to go to a DevOps team and say, don't use insecure design and don't make security misconfigurations. Okay, so that just means that write secure code is basically what you're telling them. It's less actionable. I think what I'm looking for here is more of, perhaps even at the CWE layer, do we have tools that can identify these for us? Or do we have a mechanism where we say, pick on A5, the security misconfiguration, do we have an idea of what our defaults should be and a way to be able to lint for deviations from that, or real-time monitoring in the environment where it's been deployed to say, this misconfiguration has crept in. And the reason I'm harping on that is that in the Confluence example, the vulnerability was in OGNL, a very commonly known attack surface rife within Apache struts, especially, causing lots of problems. And even early on, there was a lot of the security documentation around that said, well, there's ways to make OGNL a little bit more secure by default, but it's disabled, or it's more secure, but it's disabled by default. So if you really want to be a little bit more secure, enable these couple of settings and hope that they work. What really should be done is actually change that mentality to say, here's the secure default, go forth and conquer. So that's the bit of harping I want to do that on that, as well as just to say, it's a great list. It's good for awareness, but there's not as much meaty actionability in there, or enough guidance in terms of saying, here's what the AppSec program needs for processes, tools, the relationship between your AppSec and your DevOps team. So I appreciate the list, but I'm really just kind of moved on and looking for other things. That's where my head is.
I think you said a bunch of great things there.
Good. We can just stop the podcast there and end on a good note.
Good night. No, so
keep on going.
Have to get my 2 cents in.
Absolutely.
So first, as you were thinking there, we are DevSecOps Weekly in a way. Think about the average DevSecOps person or average developer who's getting into DevOps. Throw them at OWASP top 10 list and say, here, figure this out. Not like the results from it, but just from a scan. Just like, hey, this thing has existed for 20 years. I bet you never heard of it. Why don't you take a look at this? Completely different world, right? And this is something those of us, I don't know if I could, I'm sure at some point I could have quoted these, read them top 10 from my memory. Happily to say I don't right now. That's one thought. The second thought around this is, because that's sort of the problem here, right? And I think that's what OWASP is going to start thinking about, is as we're going over the next few years, Manesh said we don't have enough AppSec people. We all know these things. I'm preaching to choir here, but like, how do we take a document like this and start, or how do we take I don't want to call it a standard. How do we take they said document. I'll call it a document for right now. How do we take a top 10 list like this and make it something that is a little more recognized, say like the Letterman top 10 list? How about that? And then the second thought here with my jaded hat on, to answer your question about who actually uses this, it's, the consultants when I had that hat on, or a vendor doing a scan and, you need to try and meet these standards out for people. And like one of the things customers are going to ask for is, do you support OWASP top 10? Yes, sir, we do. Okay, well, what do you go do with it? My boss asked for it. So I think that's some of the unfortunate side of things. I mean, hopefully the boss is going to use it and then figure out how to triage and figure out what to attack, or figure out what to mitigate. But that's sort of where things like this come from. And I would much rather see, how do we get things better? How do we fix some of these things? So we're not talking about them week after week. We have all sorts of things that Mike and I can talk about. We can start like a SITPOT conversation, or we can talk about like IoT or different things. We don't always have to be talking about this. People, please start fixing these. Thank you. That's all.
Yes, please start fixing these. And I think what would be great here is to also see some more frameworks that come out to say, here's how you can protect yourself, or here's how to have a secure design for CSRF. For example, CSRF has dropped off because secure frameworks came out. I'll go back to, I haven't mentioned it in a while, but something like the React framework. It's a great front-end framework written by engineers from Facebook, not by a security org, that just incidentally got rid of pretty much all cross-site scripting. So these these are kind of the tools, the kind of secure defaults or the mentality I'm really looking for. It'd be great to see OWASP take this list as that shared language, the lingua franca, as you were describing, John, for consultants and others to say, here are the problems we're talking about. Here's how we define them. Now let's start to fix them. And I know we're short on time, but I did want to highlight as an example of a good kind of a survey of asecurity topics, somewhat like the OWASP Top 10. Here is a good in-depth one about API tokens. So not too much time left to talk about it other than give this article a read. Has a great example of trade-offs and thinking through why we should implement something and why we might avoid something, as well as I wanted to highlight, read it through with your hat on of engineering from an engineering perspective in terms of what's usable, what's easy for us to implement, and what makes sense for us to maintain and can be easily maintained over time, as opposed to just here is a security model that checks a lot of great checkboxes, but it's really hard to actually use on an ongoing basis. So that's my call to action. That's my reading homework for the week. What do you have for us to end the episode on, John?
I actually studied this document quite heavily last week because I just happen to be writing our authentication and authorization systems right now. And while there's a bunch of good stuff in here, the big takeaway for me, and I'm sort of curious to see or anyone else has thought about it, we've decided we're going to go with Cognito from Amazon as our authentication system. That locks me into JWT. Game over. This is a nice list of what? I think there was 10 things in here, or was it 6? But, okay, well, it is 10. Great, all sorts of things. I've always gone back in my head, Mike likes Passato, but right now Cognito offers JWT. So, and actually it's not even something I have to parse, it's handled by an API gateway. So a lot of these things are sort of taken out of my hand. Will that be like that in 3 years from now? Maybe not. But so it was interesting thing about that from a developer point of view of sometimes you get to make these choices, but often it's just sort of handed to you based off the things you're using. So I guess that's my 2 cents. We realize as much as we talk here about a lot of everything should be perfect and we want to do things the right way, frequently we make choices based off what we have. So sort of interesting.
No, that's a great message. We work with the code that we're given and the choices that we need to make. These are trade-offs. But some things are perfect, like the movie Drive and its synthwave heavy soundtrack. So go listen to that while you're reading about API tokens. I want to thank John for walking me through all of these articles this week. There was quite a bit to get through, as well as suffering through the OWASP Top 10 and finding the good bits about it so we can use that for awareness. Thanks everyone else for listening as usual. We will see you again next week on Application Security Weekly.